Sections 1.6 and 1.7 have a lot of information that you have already seen, but a little bit that maybe you haven't seen. One for sure that I know you haven't seen. But I'd like to review some of that with you today. Okay? The first thing is factoring. And I know you're going to think that's weird because that was a lot of section 1.4 and 1.5 was factoring, right? But there's some things I want you to remind you of. Let's pretend that's a 3, which is what I meant it to be. If it asks you to factor this, what are you going to do? What would you do? What would you look for first? Greatest common factor, right? We can factor out an x from each term. If I factor out an x, what's left? X squared minus 25. Is this all the way factored? It's not, is it? Okay? And this is something that I was afraid you'd forget because I mean, it's been a week since we talked about it, so I was hoping you would remember. But I just want to remind you, okay? Do you remember what this is called? Difference of squares, right? Difference because it's subtraction. Both of these terms are squared terms. So if we get a difference of squares here, we would get x plus 5 and x minus 5. Do you remember that okay? The part that'll trick you up is if you get here and you get to x squared minus 16. This is the most common one. There's others, of course, but like I said, this is the most common one. If you... can I change something real fast? Okay. What if it was x to the 4th minus 16? If you factor this out, you get x squared plus 4 and x squared minus 4. And if you put that in as the answer, it's going to tell you it's wrong. Okay? And the reason it's going to tell you it's wrong is because look at this one. That is still the difference of squares. So it's not that it's wrong per se, it's just not finished. And you've got to go one more step. X squared plus 4, because that doesn't factor because it's the sum of squares. But the difference of squares, you can get x plus 2 and x minus 2. Does that make sense? You just have to make sure when you factor all the way. And not just to where you want to stop. Okay? You okay with that so far? Okay. The next thing that's kind of in this chapter... or in this section, excuse me, is square root equations. Okay, so I just made these up a minute ago, so I don't know if they're going to be nice and friendly or if they're going to be ugly. It doesn't matter, though. Okay, so if you have a square root equation that looks like this, the square root of 3x minus 5 equals 7. How do you go about solving this equation? Square both sides, right? So if I square this side and I square this side, on the left-hand side, what do we end up with? Yeah, just 3x minus 5, right? If I'm squaring something that's being taken the square root of, I just get that thing, okay? And then on this side, I get 49. So if I add 5 to both sides, I get 3x equals 54. Oh, it does work out nice. If I divide both sides by 3 to solve, x equals what? 18. Goes in 1, 2 left over. Yeah, 18. And we know that this is correct because if we put it in here, 3 times 18 is 54. 54 minus 5 is 49. The square root of 49 is 7, and 7 equals 7. Okay? So those are relatively easy. I wasn't really worried about those, but I did that one for you because what if the problem is like this? 2x plus 3 equals x. What if it's that? Well, if I go to square both sides like I did before, it makes the problem a little bit more difficult, doesn't it? Left-hand side, I get 2x plus 3. Right-hand side, I have x squared. What kind of problem has this now become? Quadratic. How do we solve quadratics? You know, like 14 ways to solve quadratics, right? We could factor, we could complete the square, we could do quadratic formula. Okay, I guess we really know 3 ways, not 14. Okay. I was exaggerating, my goodness. Okay. But at this point, you know you have to get it equal to 0. You guys know my personal opinion on this. I like to keep my a term positive if I can. So I'm probably going to move this stuff over here to get x squared minus 2x minus 3. Because that's just how I am. That's how I roll. And then at this point, I would probably factor this. You could use the quadratic formula for sure. You could graph it. So I guess there's 4 ways. I didn't say graphing a minute ago. Okay, but we could say x minus 3 and x plus 1, because that would multiply to be negative 3 and add to be negative 2. We can do that because that first term is 1. You guys remember that. We talked about it last week, right? So I said each one of these factors equal to 0 to solve for x. So I'd get x equals 3 and x equals negative 1. And then just to make sure, I've got to put them both back into the original equation to make sure that they both work, right? Is it possible that they both work? Yes. Is it possible that only one of them works? Yes. Is it possible that neither one of them work? Yes. So I have to make sure, okay? So if I put a 3 in here, I get 2 times 3 is 6. 6 plus 3 is 9. Square root of 9 is 3. And 3 equals 3. So that one's good. Negative 1. 2 times negative 1 is negative 2. Negative 2 plus 3 is 1. Square root of 1 is negative 1. Uh-oh. That one doesn't work, does it? Do you remember what that's called? You remember what this kind of a solution is called? It's called extraneous. It's an extra solution that doing the math we got. But if you think about it, was the original problem a quadratic problem? The very original problem, was there any squares in it at all? No. Remember the fundamental theorem of algebra says the highest exponent you have is how many solutions that you get. In the original problem, there was only one exponent, right? It was only x to the first power. We only squared it to get rid of the square root. So we kind of should, in this particular problem, should only get one answer. Okay? This one works like when we solve it, but when we plug it back in to check it, it's an extraneous solution. Okay? So that one's a little bit more difficult, but still not too bad. The one that I was worried about most is if you have x plus 5 equals x minus 2. Something like this. So it's still a square root problem, right? And when I go to square, what am I afraid you're going to do? On the left-hand side, I think we got it. I think we're going to get x plus 5, no problem. What I'm afraid you're going to do on the right-hand side? X squared minus 4. That's what I'm afraid you're going to do. What I need you to do is square that whole thing, and you know something squared is that thing times itself, right? Which means I have to distribute. Someone made fun of me the other day because in your homework on your college class it says use FOIL. And you know how I feel about that? That's what babies use. Sometimes we have to treat college students like babies, so we have to say FOIL. You are better than that, and you don't need them to say FOIL to you. Okay? So here I would actually get x squared minus 4x plus 4. You okay with that? Do I need to keep solving this for you, or you got this? I just don't think it's a nice answer. I think it's probably a fraction. Want me to still do it anyways? Okay. So if I subtract x from both sides, it is a quadratic, so I want to get it equal to 0. Oops, this is a 5. Sorry about that. So I get 0 equals, let me scoot it up a little bit, x squared minus 5x minus 1. Now, does that factor? What multiplies to be negative 1 and adds to be negative 5? That doesn't factor, does it? So factoring's out. We could graph. We'd have to use the intersect function on the calculator, or the zero function, excuse me, to figure out where the zeros were, because they're not since it doesn't factor, they're not going to be nice, pretty answers. Okay? Or we could use quadratic formula. Okay? X equals negative b plus the square root b squared minus 4ac all over 2a. So I would get 5 plus or minus the square root of, well, that's 25. And then I have 4 times 1 times negative 4. So that would end up being plus a positive 4. See, I don't know the square root of 29. Do you? No. So what I'd end up with 5 plus or minus the square root of 29 over 2. And square root of 29 is not something I can even simplify. I don't even know anything that divides into 29 that I do know the square root of, right? Like some of the stuff we worked on last week. Okay? So I would just leave my answer like this. And I think, if I'm not mistaken, what your computer program would want is this. And then 5 over 2 minus the square root of 29 over 2, right? Is that what it makes you do? Okay. Oh, it does? Okay, okay. Thank you for letting me know that. Oh, nice. Excellent. You may want to show some other people in the class, because I just saw some shocked expressions. So, if you oh, okay. It only pops up sometimes? Okay. So if it pops up, then you can use it. If it doesn't pop up, don't use it. Okay? All right, any questions about the square root equations? Okay, only one more type of square root equation that I would just want you to be careful of. I'm not going to do the whole problem for you, because again, these are not easy to make up, at least not for me, off the top of my head real fast, to actually make them like reasonable to think about. So what if it's something like this? In order to square both sides, what has to be true about one of the sides? The square root has to be isolated, right? Well, the problem in this is that there's 2 square roots, right? So I just need to get rid of one of them. And when I say get rid of, I just mean move it to the other side for now. So that I have the square root of 3x plus 5. And then I have 4 minus the square root of 2x minus 1. And this is where you have to be real careful, because I'm squaring that whole side, right? So again, on the left-hand side, I'm just going to get 3x plus 5. But on the right-hand side, I'm going to come over here to the side and work. I'm going to get 4 minus the square root of 2x minus 1. 4 minus the square root of 2x minus 1. So when I distribute, I get 4 times 4, which is... good, 16. 4 times that negative square root. So that's going to give me negative 4 root 2x minus 1. Another one. Negative 4 root 2x minus 1. And then what's going to happen when I multiply this root times that root? I'm just going to get plus 2x minus 1, right? Sorry. Plus 2x minus 1, because a root times itself is just what was inside, so I'm squaring it. You okay with that? Am I going too fast? Okay, so at this point I need to combine like terms. So I have this 2x, I'm going to get it up here, and then I have a 16 minus 1, so that's a 15, and then I have 8 root 2x minus 1. Does that make sense so far? To anyone? Yes? Okay. So that's what I have right here, 2x plus 15 minus 8 root 2x minus 1. So what can I do from here? I need to isolate the radical again, right? I got to start the same kind of problem all over again. I'm trying to isolate the radical. So if I subtract 2x from both sides, and if I subtract 15 from both sides, that's nice for now. Right? Except, what do I need to do with a negative 8? I got to divide it, right? That's when it starts getting super messy. Because I have negative 1/8 x minus 5, plus 5/4 equals root of 2x minus 1. And guess what I have to do now? Square it. Yeah. To get rid of this radical, which means I have to square that whole side. And that's where I'm going to stop. Not because I can't do it, but because there's not any that are this hard on your homework. Okay, you could do this. We could finish this as a group. You could finish this by yourself if I asked you to. Okay, because it's basically just like this problem, isn't it? Where we'd have to square both sides like that and everything. It's just crazy, ridiculous numbers, fractions. You okay with that? Yes? Okay, so here's the fun part. What if it asks you to do this problem right here? X to the fourth plus 37x squared. I think I meant that to be minus 37, so I'm sorry about that. Plus 36 equals 0. What does that look like to you? Looks like a trinomial that you want to factor, doesn't it? Okay, and we could, but just bear with me for a second. Okay, we could factor that because we could figure out AC and B and all that kind of stuff, right? But we're going to just make it a little easier on ourselves. And we're going to say, I'm going to pretend, I'm going to make up a new variable and call it a U. Well, I'm not making up that variable because everybody already knows there's a U. Okay, but I'm going to say U is going to equal X squared. Right? There's not any term here that I would have to worry about. There is an x squared here, so that would be an easy conversion to u. And then there's an x to the fourth here, so that would be u squared, right? If u is x squared, then u to the fourth would be x to the fourth would be u squared. Does that make sense? I don't want to choose u to be this term right here, because then I have to go backwards to find this one. So I kind of want it to be the middle term, or the first possible term. Does that make sense? Okay. So let's make this substitution. Well, if x to the fourth, if I know u equals x squared, then what's x to the fourth now equal? U squared. Minus what? 37u plus 36 equals 0. Is that something you're more comfortable factoring? Yeah. U minus 36 and u plus 36? Except I wrote the wrong number. Can I fix it? How about 1? U minus 36 and u plus 1? Because this leading coefficient is 1, so what multiplies to be 37 and adds to, or 36 and adds to be negative 37? Jiminy Christmas. Sorry. U minus 36 and u minus 1, right? Can I solve these now? Because it's equal to 0, right? Solve these. U minus 36 equals 0, and u minus 1 equals 0. So u equals 36 and u equals 1, right? Except what are we trying to solve for? U or x? X. Now that I have an answer for u, now that I've solved for u, go back up to here. What does u equal? X squared. So instead of writing u, I'm going to write x squared. If x squared equals 36, how do I solve that for x? Yeah, square root, what we just did, right? X equals? Make my day. Somebody remember. Thank you. Plus or minus 6. And what about this one? Same thing, right? Square root of 1 equals what? Plus or minus 1. How many answers was I supposed to get? 4. How many did I get? I got 4, right? Positive 6, negative 6, positive 1, negative 1. Guys, this thing right here is called a U substitution. And we use that a lot in my master's classes. So you guys are doing master's level stuff, kind of. We'll go kind of. Kind of. Okay? It made that problem a little easier for us, didn't it? Okay? We would have gotten something different, u squared minus 36 and u squared minus 1, and then I have to factor those again because those are difference of squares. But those problems, I mean, kind of relatively easy, but the problem is when you have something more like this. What if we had x minus 14 square root of x plus 40 equals 0? If I have an x and a square root of x in the same problem, I can either get everything to one side and it would look as messy as this problem did a second ago. You remember that awful messy problem right here with all those fractions? But what if I did a u substitution instead? What if we let u equal what? What do you think we want u to equal? Square root of x. Okay, I want u to equal the square root of x. If u equals the square root of x, what is x then? U squared. Minus what? 14u plus 40 equals 0. That suddenly becomes a way easier problem. What multiplies to be 40 and adds to be negative 14? Negative 10, negative 4, right? So u minus 10 and u minus 4. And I can do that because my leading coefficient is 1, remember that. So if I set each of these equal to 0 and solve them, I get u equals 10 and u equals 4. Do I want to solve for u or do I want to solve for x? Okay, so substitute back in what you know u is. And what is u? That sounds so grammatically incorrect. What is u? The square root of x equals 10. And the square root of x equals 4. So how do I solve for x? Square it. X equals 100. X equals 16. Yes? I mean, I could check those and they would be right. Up here, right? 100 minus 140 is negative 40 plus 40 equals 0. And if it was 16 minus, well, that's 4. 14 times 4, 54, 56. So 16 minus 56 is negative 40 plus 40 equals 0. So it works, right? But if I try to do this way, it would be a mess. Okay? So these are called u substitutions. You feel okay with that? Okay. If you don't and you're working on your homework, please just ask. Okay? One of the last things in this particular section is absolute value equations. We actually just finished absolute value equations in my regular Algebra 2 class. So if we don't get all the way through these examples, you can always go to my blog and look at the videos from the absolute value equations day, because I have those videos up there. You know where they are, okay? But we'll start real easy. Absolute value of x minus 2 equals 10. Remember, I don't know if you remember this or not, but I'm going to remind you. In our textbook that we had last year, I teach this a little bit different because of my concept of absolute value. Okay? Inside of this absolute value sign, I'm allowed to have any number I want. But when I take that value out of the absolute value sign, that value always has to be positive, right? So what's inside is allowed to be positive, and what's inside is allowed to be negative. Whatever comes out is always a positive, isn't it? So I have the positive value of what's inside. See how that's just exactly what was in there? And then I have the negative value of what was inside. See, I just changed the sign of what was inside, and I still get 10 right there. Okay? So if I go to solve those, if I add 2 to both sides, I get x equals 12. If I distribute this negative sign through, I get negative x plus 2 equals 10. Subtracting x on both sides gives me negative x equals 8. Dividing both sides by negative 1 gives me x equals negative 8. And again, I can and should check those. 12 minus 2 is 10. Absolute value of 10 is 10. Good. Negative 8. Negative 8 minus 2 is negative 10. Absolute value of negative 10 is 10. Okay? Now, before you can do any of this, the positive value and the negative value, if you had something, for instance, like 2 absolute value of 3x plus 5 minus 12 equals 17, before you can do any of this positive, negative stuff, what do you have to do? Yeah, you have to isolate the absolute value equation, or part of the equation. You have to get rid of everything that's associated with that in the same order that you know how to do already. Okay, so we would add 12 to both sides. 2 absolute value of 3x plus 5 equals 29. Divide everything by 2 to get that to go to 1. Absolute value of 3x plus 5 equals, that's not very nice, is it? 29 over 2. But from this point in time, then I would go to my 2 separate equations. I have the positive value of what's inside, and I have the negative value of what's inside. Okay? Any questions about that? Do I need to finish that one, or you guys got that okay? You got it? Okay. The whole positive negative thing, as far as equations go, that's just my own personal stand against the man, you know, because it would be easy enough to make this the positive and then the negative, except when you're working with absolute value, it's not the thing that's on the outside that can be positive or negative, it's the thing on the inside that can be positive or negative, right? And when you get to absolute value inequalities, then it makes a huge, huge, huge difference. Okay, so if we just do it all the same way all the time, we don't have to worry about any of the other stuff. Okay, that's all the notes that I have for you for section 1.6. I'm going to give you just some real quick notes at the beginning of 1.7. I think most of 1.7 you've gotten. If not, we can definitely make another video or talk about that tomorrow. But at 1.7, just to remind you, you need to know the difference between interval notation and set builder notation. So I'd like to remind you of that real quick. Interval notation is going to look something like this. -1 to 9. Is -1 included as part of my domain? No, because it's a parenthesis. Is 9 included as part of my domain? Yes, because it's a bracket. Okay? So set builder notation would look like -1 is less than x is less than or equal to 9. Okay? Based on what I see in this college textbook, I've actually adjusted how I teach this section in high school. Because what we did at this point was if we graphed it, we went -1 to 9, and we did what, open circle on -1 and closed circle on 9, and it was everything in between, right? Here's what it looks like in the college work. It's not that big of a difference, but it is a little bit different. It looks like this, -1 to 9. Use exactly the same kind of symbols that you use in interval notation. And then it's everything in between. Does that make sense? It's not hard to understand, but if you've never seen it before, it might be confusing. Okay? Are you okay with interval and set builder? We worked quite a bit on that last year in actual Algebra 2, so I hope you're okay. If not, like I said again, just ask. Okay? The other thing that you have never seen before, except for in one place, is this symbol and this symbol. Okay, remember when we did interval notation and we were going from -infinity to 6, and maybe there was an asymptote on 6, and so we said, and then on the other side of 6 you went to positive infinity, like that. You remember when you talked about that? And I told you that this symbol means and this and this. Well, the actual name, and I think I told you at the time, but just to remind you, that's a union symbol. It's that and something else. Okay? So union, coincidentally, looks like a U. Okay? But there is this symbol as well. And it's the intersection. It's what two sets might have in common. Okay? So for instance, if I told you one set went from negative infinity to 5, and one set went from, let's just say, negative 3 to 8. Let's do a parenthesis on that one too. What would be the intersection of these sets? Well, you know how much a visual person I am, so let's do this. I know it looks like that. Oops, I should do that. Right? And I know this one goes from negative 3 to 8. Then what do they share in common? Isn't it just this middle part right here that they have in common? I didn't do a very good job of circling. What they have in common is from negative 3 to 5. And negative 3 is included here, but 5 is not included here, so it can't be included there. Does that make sense? Does that help at all? Again, I know you've never seen that before. We've never talked about that as far as intersection. Only time we ever used union was when we were talking about domain and range, things like that. Okay? But I wanted to kind of show you what a union was and intersection was, that kind of thing. What if it was from negative infinity to negative 3? One of them was, so it was like all of this, and then the other one was 5 to positive infinity. What's its intersection? Yeah. Oh, that was a horrible one. Ignore that one. Let's try it again. It's an empty set. There's no intersection. So the solution would be the empty set. Okay? Again, I'll repeat myself. If you have any questions while you're working, please just ask. You know I'll answer them. Okay?